In our previous video, we learned about testing for association when we had a categorical response and a categorical explanatory variable. Specifically, our categorical explanatory variable in those cases had two levels, such as having or not having coronary artery disease. Now we might want to know, what if we have more than two levels in our category explanatory variable? Notice this is similar to what we did when we went from a two-sample t-test to ANOVA. In a two-sample t-test, we had two groups, two levels of our categorical explanatory variable. In ANOVA, we had more than two groups. Now, we've got more than two groups as well. So this is all about the number of levels in a category explanatory variable. We still have a categorical response. Let's look at an example and see what this might look like. In this question, we have the relationship, where we're interested in exploring the relationship between a person's generation and their views on marriage. So the question is, do different generations view marriage differently? A 2010 survey of a random sample of American adults conducted by the Pew Research Center asked the following question: is marriage becoming obsolete? The results from the survey are shown in the table below. First, I would like you to pause this video and identify what is the response variable and what is the explanatory variable. The response variable is whether marriage is obsolete, that is, their views on marriage. The explanatory variable is a person's generation. And in this case, we have four generations, that is, four levels of the explanatory variable. There is one explanatory variable, generation. There are four levels, so that is, a person may be a millennial, Gen X, a boomer, or older than 65, so that might be, the greatest generation. So if a person is a millennial, that is, we might enter millennial in the data set, but millennial is the person's generation. So generation varies, a variable varies, but millennial is one level, one type of that generation. Similarly, we might measure whether their view is that marriage is or is not obsolete. So, this question, whether marriage is obsolete, this is the response variable. It has two levels, yes or no. Yes, people believe that marriage is obsolete, or no, they do not believe that marriage is obsolete. And the question that we want to know is there an association between this particular belief about marriage and generation? If there is an association, that means that the proportion of people who believe that marriage is obsolete changes from one generation to the next. If there is no association, then that means that each generation has the same probability of believing that marriage is obsolete, or that the probability of believing that marriage is obsolete is the same regardless of generation. So that is the idea behind association between two categorical variables. It's similar to what we saw with ANOVA, except for now we're not comparing means, we're comparing proportions. So what we want to know is there evidence of an association between generation and views on marriage? What we're going to do is we're going to calculate the appropriate conditional distribution to answer the question, or to justify our answer. We've already identified that the explanatory variable is generation. And it has those four levels of millennial, Gen X, boomer, and 65 plus. And this is a categorical variable. It would not make sense to take the average of generation. Our response variable, which we've already identified, is views on marriage. So we might call that marriage view. And this is also categorical. It would not make sense to average yeses and nos, but it would make sense to take a proportion of people who believe that yes, marriage is obsolete. So when we talk about taking a conditional distribution, we're really saying that we should calculate the proportion of people who think marriage is obsolete. But we're not going to do this overall. We're going to do this for each generation, or for each level of generation. So we're going to find the proportion of millennials who think that marriage is obsolete, and then the proportion of Gen Xers, and then the proportion of boomers, and the proportion of people who are 65 plus who think that marriage is obsolete. So we're going to have 4 proportions of people who think that marriage is obsolete. And we can do that in this table. So, of the 536 millennials, what proportion of them believe that marriage is obsolete? How might we find that? Well, 236 millennials out of the 536 that believe that marriage is obsolete. So of the 536 millennials, 236 believe marriage is obsolete, so that would be 236 over 536. So this proportion, and I'm going to actually write it a little bit smaller, so that's 236 over 536, so the proportion in this case is 0.44. How would we do this for Gen X? In Gen X, there were 729 total Gen Xers in the survey, but only 313 of them believe that marriage is obsolete. So that would be 313 out of 729 Gen Xers that believe that marriage is obsolete. So that's 313 over 729, and that's a sample proportion of 0.429. I'm going to ask you to pause this video and fill in the remainder of this table. So that is, we want a proportion of people who believe, of the boomers who believe that marriage is obsolete, the proportion of people who are 65 plus who believe that marriage is obsolete, but then also do that for the opposing views, so for people who do not believe that marriage is obsolete. So please find the remaining 6 probabilities. I hope that when you worked this out, you ended up with 35% or 0.35 for the boomers who do believe that marriage is obsolete, 32% or 0.322 for those age 65 plus who believe that marriage is obsolete, and then proportions of 0.56, 0.571, 0.650, and 0.678 for the respective proportions of people who do not believe that marriage is obsolete for the millennials, Gen Xers, boomers, and those 65 plus. We can also see that these proportions of those who do and do not believe marriage is obsolete in each category should sum to 100%, or a probability of 1. We find the probabilities of those who do not believe that marriage is obsolete, by taking the number of those who do not believe marriage is obsolete and dividing by the total in that category. So for example, for the millennials, there were 300 people who did not believe that marriage is obsolete, and 300 divided by 536 gives us the 0.56. What we now want to look at is this graphical distribution of marriage views given the generation. So what I'm going to do is I'm going to plot these probabilities. There are 4 generations, and so generation is what's going to go along my x-axis, because I have conditioned, or because I have looked at within each generation, because it's my columns that sum to 100%, those are the things that go, it's the columns or my generation that goes along my x-axis. So I'm going to have millennials, Xers, boomers, and 65 plus along my x-axis. So because I've conditioned on generation, because I'm looking at millennials and Xers, boomers, and 65 plus, those levels of my categorical explanatory variable, my explanatory variable is what's going along my x-axis. Now what I'm going to do is I'm going to say, well, because I know that each column sums to 100%, I can draw a box that goes up to 100% for each category. I know that in total I've got 100% response rate. But then what I need to do is I'm going to break it out so I can get an idea of relative to that 100% of total, what proportion agrees with yes, marriage is obsolete versus no, marriage is not obsolete. So in my millennial group, 44% believe that marriage is not, 44% believe that marriage is obsolete. So 44% lines up to about here. So that is my lower portion. My upper portion is no, and I'm going to shade that in. So this upper portion is about 56% and the lower portion is 44%. I'm going to do the rest for my Xers, Boomers, and those who are 65 or older. For my Gen Xers, 42.9% or 0.429 believe that marriage is obsolete. So this line should be just a little bit lower. And I'm going to shade in no again. Let's do the same thing for my Boomers and those who are 65 or older. Boomers believe that marriage is obsolete with only 35% probability in our sample, and so that is down about here. And then I shade in the 65% who believe that marriage is not obsolete. And those who are 65 plus, they have a 32% chance in my sample of believing that marriage is obsolete. So that is yes. No gets shaded in above. And there we have it. And I'm going to draw in a little key as well. So yes is unshaded. No is shaded. And that's my key for whether marriage is obsolete. What we have just created is called a stacked bar chart. We have two categorical variables. One categorical variable is my explanatory variable, and that's along my x-axis. The other is my response variable, and that is whether marriage is obsolete. And we have broken it up into yes and no, and we have now represented the relative proportion of yeses and nos in each level of my explanatory variable. So, looking at this plot, we now have kind of a picture of whether there is an association between these two variables, marriage views and generation. What do you think? How would you interpret this plot? Does it look as if there is an association between marriage views and generation? That is, does the probability of believing that marriage is obsolete seem to change as generation changes? I would say yes. It appears that in the younger generations, that is, for millennials and Xers, the proportions are higher. For believing that marriage is obsolete. Than for the older generations. That is some evidence of association. Remember, if there is an association, that means that the probability of success or the probability of being in one category for the response changes as the explanatory variable also changes. So let's look at this a little further. Two categorical variables, such as marriage views and generation, are independent if the population conditional distributions for one variable are identical at each category of the other variable. That is, if the probability of being in one category for one variable does not change for levels of the other variable. So what would that look like? That would mean that the probability for millennials is the same as a probability for Xers, is the same as a probability for Boomers, is the same as a probability for those who are 65 plus. And we could even write this, because these are all the same, we could say this is the same as pi overall, that there is just some overall probability of believing in marriage probability of belief in marriage views. This comes from a rule of probability. We can say two events, A and B, are independent if and only if the probability of A given B equals the probability of A. So what does that mean? Well, A and B are events. So that would be like flipping a coin and rolling a die. So if we flip a coin and if we roll a die, those are two independent events, because what happens on we flip a coin, that doesn't influence what happens when we roll the die, and vice versa. So what this notation says, the probability of the outcome on A given the outcome of B, that's just the probability of A. So the probability of getting heads when we flip a coin, given that we get a 6 when we roll a die, well, that's just the probability that we get heads on the coin, because those are independent events. We could also say that the probability that we get a 6 when we roll the die, given that we get heads when we flip the coin, that's still just the probability we get 6. Again, because that flipping a coin and rolling a die are independent events. They don't influence one another. The coin and the die don't talk to each other. They don't collude behind closed doors and say, let's change each other's probabilities. They just don't influence each other. And so we're going to use this handy rule here to help us test for independence elsewhere. So this right here, this right here, this is a conditional probability. This is saying the probability of A conditioned on B is just the probability of A if A and B are independent. That's like saying the probability of believing in obsolete marriage is, given that you're a millennial, well, that's just the probability of believing in an obsolete marriage if generation and marriage views are independent. So that's where this is coming from. That's our motivation. So we need something like this pi overall. This pi overall would be the probability of A here. So in our sample, because we don't know these true proportions or these true parameters, in our sample we'll use a p hat overall, kind of like we did in our two sample z-test for proportions. The overall proportion of people who believed in an obsolete marriage was 1,018 over 2622. There were 1,018 people who believed that marriage was obsolete, and there were 2,622 people in the sample altogether. And that gives us an overall probability of people who believe that marriage is obsolete regardless of their generation of 38.8%. So regardless of the generation, in our sample, 38.8% of people believe that marriage is obsolete. So if A and B are independent, that is, if marriage views and generation are obsolete, if marriage views and generation are independent, then we would see something in our sample that looks like this. 38.8% of millennials would believe that marriage views are obsolete. 38.8% of Gen Xers would believe that marriage views are obsolete. Same for boomers, and same for the greatest generation. But that would also mean that the complement is true, that 61.2% of millennials do not believe that marriage is obsolete, 61.2% of Gen Xers, 61.2% of boomers, and 61.2% of the greatest generation do not believe that marriage is obsolete, for a total of 100% in each category. What would our plot look like? Well, we're still plotting a conditional distribution of marriage views given generation. Generation is still our explanatory variable, so I'm still going to have millennials, Xers, boomers, and those who are 65 plus. And I'm going to use the same key. So if it's unshaded, this is going to be yes. If it's shaded, that's going to be people who believe no for our marriage views. What does this plot look like? Pause the video and fill in the plot and see if your completed plot looks like mine. All right, so this is what I got. Because we're assuming in this case, what we're trying to figure out in this case what it would look like if they were independent, everyone is going to have the same probability of success. So we would have 38.8% for millennials, Xers, boomers, and those who are 65 or older. And so we would have a straight line all the way across at 38.8%. So remember this important note. Independence does not mean 50%, right? So remember the example of the coin toss and the rolled die. In that case, there are independent events, but getting a 6 when we roll the die is still 1/6. It doesn't suddenly become 50%, right? So in this case, if we have independence, then we would expect 38.8% of millennials and Xers and boomers and 65 plusers to believe that marriage is obsolete. Independence does not mean 50-50, even if there are two choices. Independence just means the same probability for all groups. Just as when we were thinking about ANOVA, if there were no association, it just meant that all groups had the same mean. Not a specific mean, we don't know what that mean is, it just means that the mean stays the same across all groups. Here, with proportions, if they are independent, it tells us that the proportion stays the same across all groups. It does not tell us what that proportion is, and it definitely does not tell us that the proportion is 50%. So that is an introduction to this idea of independence between categorical variables when one of those categorical variables, namely the explanatory variable, has more than two groups. In the next section, we're going to talk about how do we test categorical variables like this for independence.